I'm Brandon Cichon, and we're going to go over the death of Mr. Fees. So our situation is just before 6 p.m., students enter the classroom to find Mr. Fees dead of an apartment homicide. Apparently everyone saw it coming. At 6, the temperature of the body is 80 degrees Fahrenheit, while at 7 p.m. it was 75 degrees. If the room is kept at a constant temperature of 70 degrees Fahrenheit, what is the time of death? Okay, so the formula we're given to work the whole problem is Newton's law of cooling, which is temperature times time, which is equal to temperature ambient plus temperature of the object minus temperature ambient times e to the power of negative k times time again. So the first part we're going to be working on is part A, which is determine and discuss the value of k. So we're looking for k. So we're going to just input the values into this formula. So time is going to be 1 because of the hours from 6 to 7 p.m. That's just a time span of 1 hour. So that'll be our time, but our regular temperature is going to be 75 degrees times 1, which is equal to 70 degrees, which is our temperature ambient plus, and our body temperature is going to be the temperature of the object, so that's 80 degrees minus 70 degrees times e to the power of negative k times time. But in this instance, time is only a value of 1, so we can just keep it out. It's not really going to make that big of a deal if we leave it out. So now we just solve it like a regular equation. So now we have 75 degrees on the left-hand side is equal to 70 degrees plus 10, because we subtracted 80 from 70, times e to the power of negative k. And then we can't go ahead and add these two values because of the fact that 10 is being multiplied by e. So we're going to just have to subtract 70 from both sides. So we end up with 5 degrees on the left side and 0 on the right side, so 70 gets canceled out. So that is equal to 10 times e to the power of negative k. So to find k, we're going to have to work down. So we're first going to have to get rid of the 10, which is in front. So we're going to divide 5 by 10. So that's going to become 5/10 is equal to e to the power of negative k, but 5/10 can also be simplified to 1/2. So we're just going to go ahead and work with 1/2 because it's smaller. So we get 1/2 is equal to e to the power of negative k. So now that we get that, we're going to turn it into logarithmic form. So we're going to rearrange this into ln times 1/2 is equal to negative k. Now the next step is to get rid of the negative 1 in front of the k, because there is an invisible negative 1, so we just get negative ln times 1/2 is equal to k, positive k. Okay, so I'll just go ahead and put that inside the calculator. And we get 0.69314718006. So I'll just go ahead and put that. 7186. And this is our answer for A, which is determine the value of k. So now we're going to go ahead and work on step B. And for B, we're going to go ahead and use the same formula from the start, but we're just going to use a little bit of different numbers for variables. So our temperature is going to be the same. It's going to be 75 degrees, but our time is what we're looking for because we're determining the time elapsed to the nearest tenth from the time of death to time of discovery. So that's going to be equal to 70, because that stays the same, plus, and this is where it changes up a little more. Instead of 80 degrees, we're going to use 98.6, because this is your body temperature while you're alive, or it's at least supposed to be. And we're going to subtract, I'm sorry, I put an addition sign by 70 again, times e to the power of negative k times t. Okay, so by process of elimination, we're going to get 75 degrees is equal to 70 plus 28.6 times e to the power of negative k times t. So like the first part A, we're going to go ahead and just subtract 70 from both sides, so we get 5 on the left side is equal to 28.6 degrees e to the power of negative k times t. And then just like the first problem, we divide. So we get 5 divided by 28.6 equal to e negative kt. Okay, so then we're going to want to just rearrange this into logarithmic form to get rid of this e. So we'll get rid of that, and we'll just put ln 5 divided by 28.6 is equal to negative kt. And then I can go ahead and get rid of this negative k, which is in front of the t. So this will become ln 5 divided by 28.6 divided by negative k is equal to t. And if I go ahead and put that in the calculator, then 5 divided by 28.6 is equal to divided by negative. And we ended up getting 2.5. And that's equal to 2.5, and it's going to be 2.5 because we're going to the 10th place, because that's what part B asked for, and that's going to be equal to our time for part B. Now the final part, part C, we're going to be determining and discussing the approximate time of death. So this is probably the easiest part, because from 7 p.m. That's what we start with, because that's when Mr. Fees' body was found. So we're gonna go ahead and just subtract 2.5 hours from that. So we can just get rid of 1 hour, so 7 minus 1 hour is gonna be equal to 6 p.m. Subtract by another hour, so 6 minus 1 is gonna be equal to 5 p.m. and then subtract a half hour. That's gonna be equal to 4:30 p.m. and this is when we have the time of death for Mr. Fees.